Hi, in this video we're going to talk about the difference between sensitivity and specificity. Let's get started. Let's start by discussing sensitivity. Sensitivity is going to be your true positives, your true positive rate. In other words, how well can the test or the tool detect those with the condition or disease? Let's say you have 100 people that have strep throat, and you develop a test to detect whether or not a person has strep throat, and you administer this test to all 100 people. If your test isn't that sensitive, what's going to happen is of the 100 people that you tested, a small number are going to test positive. So let's say of the 100 people that you tested, 25% or 25 individuals test positive. Your sensitivity is going to be 25%. This is because 25 out of the 100 tested positive for strep, and in reality they do have strep, so they are truly positive. If the test isn't very sensitive, you're going to get a lot of false negatives. In other words, a lot of people are going to take the test, they're going to test negative thinking that they don't have the disease, when in reality they do have the disease. In our example, 75 out of the 100 people tested negative, even though in reality they do have the disease. So these are going to be your false negative results. And as you can see, there's quite a lot of them if the test isn't very sensitive. In real life, this would translate to missing a lot of COVID cases, for example. You could miss a lot of flu cases, a lot of hepatitis A cases, and all these diseases that I mentioned are quite contagious. So if we're missing a lot of these cases, well, then this allows these diseases to spread even further, and we're not able to catch these diseases early on to then provide that treatment early on. So that's why we want the sensitivity of a test to be as highly sensitive as possible. Let's say you make a new test, one that is more sensitive, and so you administer this test to all 100 people, and out of the 100, 90 test positive, and the remaining 10 test negative. This is a much better situation to be in because we're not missing as many of those cases as we were before. To calculate your sensitivity, aka your true positive rate, you take your true positives divided by your true positives plus your false negatives. Keep in mind that all 100 people have the disease, but only 25 out of the 100 tested positive. So those are going to be your true positives because they tested positive and in reality they do have the disease. So they are truly positive. And as for your false negatives, 75 out of the 100 people tested negative when in reality they do have the disease. So your false negative here is going to be 75. Together you have 25 over 100. Simply put, 25% of the people tested positive and in reality they do have the disease. So they are truly positive. In our high sensitivity example, the true positives is going to be 90 because 90 out of the 100 people tested positive and in reality they do have the disease. And as for our false negatives, 10 out of the 100 tested negative even though in reality they do have the disease. So our false negative is going to be 10. So put together, we get 90 out of 100. Our sensitivity rate is 90%. So to quickly summarize, sensitivity is going to be your true positive rate. In other words, what percentage of people tested positive and in reality also have the disease. If the sensitivity is low, you're going to have a lot of false negatives, meaning you're going to miss a lot of cases. So we want the sensitivity rate to be as high as possible. That's it for this video. I hope this video helps. Please like, subscribe, comment, and share.